for week number 4, curve properties using derivative. Okay. Alright, so you have 2 lessons. Okay. You can see lesson number 1 have 4 subtopics to cover, and lesson number 2 another 3. Okay. The most important for these 2 lessons is usually in the year 1, usually we focus on for the especially for higher derivative, and also maximum and minimum point. Okay, but some of the chapter they ask for the point inflation actually is very closely related, these 2 lesson. Okay. Okay, so we start with the recall from the previous chapter. Okay, last time in week number 2 and week number 3 we discussed about the derivative part 1 and part 2, right? Okay, so therefore we just do a quick recap about the previous lesson. Okay. Alright, so we have over here this is a table of differentiation, table of derivative for function, of function. Let's say you have a constant differentiate y equal to c. The derived function will be f prime is equal to 0 because there is no slope for straight line, especially your straight line is a horizontal line or vertical line. There is no slope unless you have a straight line that include a gradient, so you can differentiate the function in order to get the derivative. Okay. Next, for the polynomial y equal to x power of n, what is the derivative? Yes, definitely. You bring down the power which is n in front of your x, and then subtract 1 from the power. Alright, next, composite. Composite function y equal to x plus a power of n. So our y prime is, do the same thing like this polynomial, bring down the power in front, copy the function, nothing happened to the function right now, and what happened to power? Power minus 1. And don't forget to multiply with, you differentiate the function inside the bracket. Always do that. Okay. When you have a derivative, remember your end product, your end, the last term, will be a multiplication with differentiate the function inside the bracket. Either you have an exponential ke, you have a natural logarithm ke, or you have a trigonometric function ke, you stop, the last term will be multiplication with the differentiate the function. Okay, so now back to this table, exponential function. Y equal to exponent of fx. So our y prime is, it's very simple, copy the equation and then again stop with multiplication of differentiate the function of fx. Alright, next, again exponential function, but this time you have your base with number. For example, y equal to 4 of x squared, for example. Okay, so the derived function for this exponential function, your base is a number, is very simple. Copy whatever you have from the question. Kali ini kita ada 3 term ya. First part is copy the question. Second, apa dia? Ln your base. In our case, ln 4 lah. And then last but not least, again stop with multiply your the differentiate of your fx. Okay, last but not least. Oh, not the last one. Natural logarithm. Y prime is equal to 1 over function. 1 over function. Let's say your function over here is an exponential. Just copy whatever your function is. And then multiply with, stop with f prime x. And you can see, start from the composite function. At the end of your term, your last term will be differentiate the function. Okay. Apatah lagi for your trigonometric. You can see from here, your end result, your last term would be differentiate the function. Okay. The first part, you just simply differentiate the trigo. This is your trigo. Differentiate sine become cos. Differentiate cos, negative sine. Differentiate tangent is secant squared. But the function over here remain as from the question. Okay, right. So this table, don't worry, is usually given in the question. Don't worry. Okay, straight away we go to the first subtopic. Higher derivative. What is the definition of higher derivative? Higher derivative are obtained by successively computing the derivative of a lower order derivative. Contoh, let's say you have, for example, y, you differentiate y, in terms of x, you have y prime. From the lowest, you can see from here, this is y. If you differentiate, become y prime. Differentiate y prime, become y double prime. So you can see the prime number over here is increasing. And differentiate y prime, become y triple prime. And this one is unstoppable process. You will obtain up to y with power of n. So therefore, the definition of the higher derivative is successively computing the derivative of a lower order derivative, meaning you differentiate from the lowest prime to the highest prime. Okay, macam mana nak reverse balik? Actually, you are going to use the integration. Tapi yang that one is on the week number 7 later lah. Okay, moving on, the notation of the higher derivative. Okay, it's very simple. Yang ni ada dalam table dan delta. Okay, for the first derivative from fx become f prime. How about the Leibniz? Actually, Leibniz is a guy. I'm not really sure about the history, but this is the name of the founder of the notation. Okay, there will be, you have dy over dx. Second derivative, you have f double prime over here, d squared y over dx squared. Moving on. Okay, over here you have triple prime dx cubed. How about the n derivative? You just simply put as fn of x and then dny over dx power of n. Okay, this is for Leibniz notation. Commonly used is prime, or some books they use the Leibniz notation. This is up to you actually to choose. Both are correct. Moving on. So over here, I'm not going to discuss the whole question from the slide given. I choose only two questions, number 6 and number 7 actually. So number 6, determine the third derivative. They wanted to know what is the third derivative of this function. Third derivative means y triple prime or d cube y over dx cube. Okay, so we go one by one. Question A, y equal to 6x power of 4. Y prime is 24x power of 3. Remember, bring down the power and then subtract power with 1. Okay, since you bring down the form, therefore 4 should be multiplied with 6, so become 24, and subtract with 1 of your power. So how about the second derivative? Bring down the 3, multiply with 24, becomes 72. Power minus 1 is 2. Y triple prime, 72 times 2 is 144. And then power minus 1, so 2 minus 1 is 1. So this is the final answer. Okay, how about B? Y equal to sine x. So y prime, differentiate sine, is cos. Copy the function back, but over here remember, differentiate the x. Differentiate x equal to 1. So first derivative is cos x. Double prime, differentiate cos is negative sine. Okay, the third derivative would be negative. This remain because it's a coefficient similar to this function. I keep the 6 over there and I just bring down the power in front, so 6 times 4. So in our case, negative 1 is the coefficient to the sine. So Negative 1 is the coefficient. So differentiate sign is a cos. So you have final answer will be negative cos. Alright, moving on. So number 1 at question A and B is done. Question C. Y equal to exponent negative 2x. So y prime. Remember? Differentiate of exponent of function is number 1, copy semula and multiply dengan differentiate the function. Okay, so in our case, just copy saja and differentiate negative 2x become negative 2. So final answer will be negative 2 exponent negative 2x y double prime. Again, copy semula soalan is very simple. And then differentiate the function negative 2. Simplify for exponent negative 2x. Triple prime. Copy semula is very simple. Takkan tak tahu copy, right? And then differentiate with power. So final answer will be negative 8 exponent negative 2x. Okay, moving on. Question D. Question D. Question D. A dah, B dah, C dah. Okay, D. Y equal to ln X. Yang lagi, differentiate natural logarithm. Y equal to ln X. Y prime. Dia jadi 1 over X. Right, so Y prime 1 over X. But usually we bring up the denominator, is become X power of negative 1. Proceed. Second derivative. This one is similar to question A. Bring down the power, power minus 1. So bring down the power, negative 1. Negative 1 minus 1 is negative 2. Double prime, sorry, triple prime, the third derivative. Negative 1 multiply negative 2. X, simply copy the X. Negative 2 minus 1 is negative 3. So final answer 2 exponent. So exponent 2x power of negative 3. Or you boleh bring down. Okay, moving on. Question E. Y equal to x squared. Y prime is 2x. Y double prime is 2. Y triple prime is 0. Remember, differentiate constant is 0. Okay, moving on. Question number 7. Most of your friends ask me, sir, how to answer question number 7. Okay, actually number 7 ni, you have to use your basic understanding of differentiation in the general form, because they will never use any function, but they let some of the power become a constant. For example, the question asks, write an expression for the n derivative of each of these function, meaning you have to differentiate up to the n term. Okay, biasanya kita differentiate the first derivative, the second derivative, the third derivative, right? But they wanted to know what is the f(n)x, or in the Leibniz, d(n)y dxn. Okay, we start from the basic one lah. Question A. We start from question A. Okay, the first derivative, y equal to x power of n. The first derivative. Bring down the power, power minus 1. Second derivative. Bring down the power, so multiply with n. N minus 1, n minus 1 minus 1 n minus 2. L triple prime, again n minus 1 n minus 2 x n minus 3. So I believe you can see the pattern here. So what is our yn? Alright, so if you can see from here, this is actually a factorial form. Remember, n factorial equal to n minus 1, n minus 2, n minus 3. You subtract 1 to the next term. For the next term, you must subtract with 1, 3, 2, and 1. So you have n factorial here. Usually we take only the highest term. Which one is the biggest? N or n minus 1? N is the biggest. So therefore you have this n factorial. Okay, how about the x with power? You can see from here, when you have y prime, you have 1 at the end. And you have 2, you have 2. When you have 3, you have 3. So therefore, n minus n. But n minus n is 0. Any number power 0 is equal to 1. So yn equal to n factorial. Okay, B. Y equal to x, n minus 1. Y prime equal to n minus 1, x, n minus 2. Why we have minus 2? Because n minus 1 minus 1. Therefore, you have minus 2. Moving on, you have y double prime. N minus 1 multiply n minus 2. Mana datang n minus 2? You bring down the power, remember? And then n minus 2 minus 1 is n minus 3. Okay, how about y triple prime? Again, n minus 1, n minus 2, n minus 3. Mana datang n minus 3? Bring down the power, put in front, multiply with the rest of the coefficient. So you have this kind of format. So therefore, subtract with 1 of your power n minus 4. Then what is yn? Okay. Alright, so I just want to highlight a few things over here. You can see, let's talk about the coefficient. When you have y prime, you subtract with 1 at the end. When you have double prime, the last coefficient is n minus 2. When you have triple prime, you stop at 3. So, actually, you akan dapat n minus 1, n minus 2, n minus 3 sampailah n minus n. Okay, so you can see n minus n is 0. Any number multiply, no need to check for the power, because power ni actually, if you wanted to know the power, okay, when you have first derivative, you have first derivative, you have 2. Seems like 1 plus 1, right? Okay, so actually you have power of n minus n plus 1 here. So this one I replace with 0. Open the bracket over here, n minus n is 0, so x power 1. Oh, sorry, minus 1 I think. Minus 1. Don't bother with the power. As long as multiply with 0, the whole thing become 0. Okay, number 1 done. Number 2 done. Okay, let's skip for C. I want to proceed to D. For D. Okay, D. Y equal to exponent of x. Y prime. Remember, differential exponent, you have your exponent back. Double prime, again you have your exponent back. While triple prime, you have exponent your back. And then for the n term of the n derivative, the answer will be exponent of x again. Okay, E. Y equal to exponent of 2x. E. So y prime. First, copy your question. Multiply, differentiate your function. Differentiate 2x is 2. So 2 exponent 2x. Second derivative. Copy your question back. Nothing happened to the question. After that, baru you multiply, you differentiate the function. Multiply with 2. 4 exponent 2x. Actually similar to 2 times 2. Or sorry, not 2 times 2. 2 power of 2. 2 power of 2. This one is 2 power of 1. Exponent 2x. So can you guess for yn? The n derivative? Yes, 2 power of n. Exponent of 2x, because you still have the exponent of 2x again and again. Alright, so for question number 7, wait, give me time to copy this one. Put a while for this increasing. Okay, number 7. Most of your friends stuck over here, which is number 7 for f. Y equal to ln x. Okay, y prime is 1 over x, remember? Or x power of negative 1. Y double prime negative 1, x power of negative 2. Or negative x negative 2. Y triple prime negative 1 times negative 2, x power of negative 3. So 2x power of negative 3. And you can see from here the pattern. Now they change from positive for the first derivative. Second derivative is become negative. So positive, negative, and then they change back to the positive. Okay. So what we can do over here is consider for the coefficient. Yeah? Consider for the coefficient. So therefore, for this part, okay, one for this increasing. Okay. Sign. Let's talk about the sign first. A bit different over here. Sign of the sequence. Y prime is a positive. Y double prime negative. Y triple prime is a positive. Y power 4 is a negative again. Okay, how about yn? Okay, so we decide to use negative 1 power of n minus 1 as the coefficient. Because let's say you have 1, the first derivative, right? The first derivative. So 1 minus 1 is 0. One minus 1 is a 0. So negative 1 power 0 is equal to 1, right? Any number power 0 is a 1. Okay, negative 1, 2 minus 1, 2 minus 1 is 1. So you have negative 1. So you can see the pattern, negative 1, 3 minus 1, negative 1 power of 2. So it become 1 back. So we start with positive, negative, positive. So they satisfy the coefficient of the sign for the derivative of the natural log. Okay, so negative 1 power of n minus 1 is the coefficient. Okay, now back to the term over here. Okay, so if you have if you have the third derivative, okay, the number will stop at 2. I can guess when I have when I have a derivative of 50, okay, my last term would be negative 49, which is the minus 1 from the coefficient, minus 1 from the coefficient. So just now kita dah decide the coefficient for yn is negative 1 and minus 1, and then the number ni dia akan start from 2, 3, and then they stop at n minus 1. Okay, and then your x, look carefully for the power. Now when you have 1, you have 1. When you have 2, you stop at 2. When you have 3, you stop at 3. Is it? So therefore kat sini you akan dapat negative n. Alright, so to finalize, your yn will be negative 1 n minus 1 n minus 1 factorial, because this is a multiplication. Remember, for the factorial, n minus 1 factorial is equal to n minus 1 n minus 2 sampailah 3, 2, 1. Actually the reverse the process lah. Okay, actually in the ascending order, for the factorial they start for the descending from biggest to lowest, but this one they use from lowest to highest, ascending order. Right, so therefore you have negative 1 n minus 1 multiply with the n minus 1 factorial, okay, over x power of n, because you have negative n as a power, so we can bring down the power, put as a denominator. So this is the final answer. Right, so that's it. So our next video will be increasing and decreasing function. Okay, so if you have any question, just let me know. Thank you.